Here in section 12.4, we want to look at a hypothesis test for the significance of our correlation coefficient, the R. The reason we want to do that is because the coefficient of correlation R measures, again, the strength and direction of a linear correlation between X and Y, but that's in the sample data. So the question we want to know is, does this correlation, does it also apply to the population? Because remember, in inferential statistics, we want to generalize from the sample to the population. So if it is a significant correlation, then that'll tell us it applies to the population. And that's also telling us whether the regression is reliable. So to answer this question, we need to consider not only R, but also N, the sample size. So we'll need a measure that depends not just on the correlation coefficient, but also the sample size. If that relationship extends to the population, we say that correlation coefficient R is significant. So significant means the relationship extends to the population, which is what we want, which means it is not likely that a significant sample correlation occurred by chance if there's no relationship in the population. So significant, it extends to the population. It's not just due to chance. So we're going to use our familiar steps with hypothesis testing like we did before. So we're going to look at example 12.3, example 1 again. So going back to our Netflix example. And so for 12.3 example 1, we need to, step 1, determine our null and alternative hypotheses, H0 and HA. So H0 here is going to be that there's no relationship in the population. HA is going to be that there is a relationship in the population. So the slope of the population regression line is rho, and we'd like to show, we look back at our sample data here, we had our B, which is the slope of the regression line for the sample, was 0.123. That's positive. It's not big positive number like 10 or 100. So we may just want to test and see if instead of rho greater than 0, because it looked like beta was definitely positive, but it ended up only being 0.12 slope. So we may want to test rho greater than 0, or we might just want to test rho, which is the population slope, not equal to 0. We'll go ahead and test rho greater than 0. So this will be rho greater than 0. And then the opposite is our null hypothesis, which would be rho, that's Greek letter rho, looks like a P, it's not a P, less than equal 0. So remember, these two have to be opposites. Step 2, determine our distribution. For t-tests of the regression coefficient or the correlation coefficient, we always use the t-distribution. Compute our test statistic. So our test statistic here is R times root n minus 2 over root 1 minus R squared. So you could plug in your correlation coefficient and your n, plug that into the calculator. However, when we did our regression on the calculator, it gave us that value. So the t is right here, 26.2569, so 26.3 approximately. Determine your p-value. Usually that's two-tailed. Here our p-value was, this is one-tailed because we did a greater than. 2.37, the e negative 9 means times 10 to the negative 9. So here our p is equal to 0.00000000238. So I move that decimal place 3, 6, 9 places to the left. That's what the negative 9 means, E negative 9. And this is definitely less than 0.05, which is our typical significance level. So now we make our decision, P less than alpha, which is what happened here. We're going to reject H0. So our decision here is to reject H0. And now we'll go ahead and state and interpret our conclusion. So we would say that there is significant evidence to believe that rho is greater than 0. Which means that there is a linear relationship. So there is significant evidence to believe there's a linear relationship. Positive linear relationship. So let's put a plus in front of there. So actually, when we go back to our null alternatives, so our alternative, what we're trying to establish is positive linear relationship. That's what rho greater than 0 means. And then the opposite is that there's not. So no positive linear relationship. Now, if you're doing equal, 0, not equal, so an equal, not equal would just be linear relation, no linear relation. Because remember, when R is 0, that means no linear relation. So we're not doing the computing here. We're just using the output from Lin-Reg t-test. So that Lin-Reg t-test gives you everything that you need to make your decision.